welcome back to another episode of converting my Toyota pickup to all electric. Today is going to be an exciting one. As I mentioned before, we're going with a 144 volt battery pack in this new setup. And in this video, I'm going to show you guys how I mounted this high voltage battery enclosure beneath the bed of my truck. This is going to house all the high voltage batteries and the battery management system for the new setup. It's going to be robust. You're not going to be able to see it from the street. It's only going to have the good stuff, very unsuspecting. So let's get started and I'll show you guys how I did it. What's up guys, welcome back to the channel. It's another episode of me converting this old Toyota pickup truck to all electric. And today we're going to do some work mounting the high voltage battery pack. So this battery pack is going to be 144 volts, 230 amp hours. That's going to use 6 individual modules out of a 2014 Tesla Model S. So 6 of these bad boys right here. Going to give me around 30 kilowatt hours of capacity, should be about 100-mile range, maybe a little bit more. From the factory, these are liquid cooled by Tesla because they have much higher amp draw than what I will be using. I'll be using maybe 300 or 400 amps peak, but these are the coolant inlets and outlets if you're using them in a higher power application. So a brief overview of the high voltage battery enclosure here. We have a fully welded 3/16 thick aluminum battery enclosure from EV West. This is their 4, 5, or 6 module Tesla battery enclosure. I believe these were made for Volkswagen bus conversions, but if you're creative, you can use them in a variety of applications. I'm going to try to house 6 battery modules in here. Should be about 300 pounds because they're just over 50 pounds each. You can see some factory cutouts on the side here that comes this way from EV West. You're going to have a maintenance or disconnect switch here. You're going to have your high voltage connection here. And then there will also be some BMS wires coming out of here. So it's nice that these are factory cut. Should be able to get a good weather seal around them and keep water out of here. But my plan is to cover the myriad of connections that come out of this box in a different video. Today I want to just cover the actual structural mounting of the battery pack. This is going to be rigidly mounted beneath the bed of the truck to the actual frame using these mounting points all around the perimeter here. So let's take a look and talk through how that's going to happen. So going towards the back of the truck here, we look down underneath, you can see the bottom of the frame here is in pretty good condition. And the plan is to weld a number of cross members between the 2 frame channels here to provide mounting points for that battery enclosure. And for anybody worried about clearance, first of all, this truck is only going to be on paved roads. Second of all, the diff is only 7 inches off the ground. The bottom of the battery pack is going to be about 10.5 inches off the ground. So we should be all good there. And to do that, I have picked up this steel angle here. This is mild steel. I got 3 pieces of it in 4-foot lengths. If you're wondering, it is 1.75 inches square and it's 3/16 inch thickness. Now, if you're wondering how I sized the material for this sort of battery mounting system that I'm throwing together, first of all, it's important to consider static versus dynamic load. So, if I have something like a workbench that I'm designing for, it's never going to move. You might be hammering on it, but it's never going to experience any sort of sudden jolts. So when you're designing something like this, you consider a static load of say 300 pounds if that's what you're going to have on top of it. When you're designing something that's going to be going down a road and going over bumps, starting and stopping, you want to design for a dynamic load. I didn't do any sort of complicated calculations for this. I just did some back of the napkin type of stuff and tried to be really conservative with my estimates. So first of all, as I mentioned, the battery pack is going to be around 300 pounds. And that 300 pounds is going to be roughly evenly distributed across 2 or 3 cross members. However, when I was sizing this, I made the assumption that the 300-pound load would be acting in the center or the midspan of the angle, which is where it would be weakest, and fail under the lowest amount of weight. So there's a sort of built-in safety factor there. I also multiplied the load by about 5. Since it's a dynamic load, you typically multiply it to between 5 and 10, the static load. So then I sized this for 1,500 pounds, acting directly in the center of a 4-foot span. After I got the thickness required from that, I went one size up, and that's how I ended up here. Should be very robust, should have absolutely no problem supporting a 300-pound battery pack. If you wanted to be more precise, you could build your battery enclosure in CAD and run some tests on it, but for me, this was quick and dirty, and I feel pretty safe about it. So enough yapping. I've grabbed some dimensions already for the underside of the truck here, and then also for the battery enclosure. They do have a drawing of the battery enclosure online, but good just to double check because some of these might be an eighth or a quarter off on the mounting tabs. So let's double check all this work, and then we can start cutting these down to length and tacking them in.
So we've got almost exactly 41 inches inside frame rail to inside frame rail. Wonder if that shrinks at all if we go back. So what I'm gonna do is have one beam run across here and another beam run across the inside of the C channel back here.
While I'm laying this out, I'm also thinking about the high voltage disconnect. The maintenance switch here is going to be most accessible if it's on the back of the truck, like underneath the tailgate. And then having these connections on the left side also makes it pretty easy because the controller wiring is going to come up through right here, and then I have this enclosure, that one, going right here, so I can drop down and those connections will land right about here. So we're gonna weld this piece in first. Let's cut this down to 48 inches. Grind the edges here and chamfer them a little bit, one so that I have a little bit of room to fill in on the welds, and also so I could have a nice clean substrate to weld to.
Let's see how we did with this first one. Should be a snug fit in here. And that's great, because since this is resting inside the channel, it's sort of like a positive contact. So in addition to our welds holding it up, the bottom of the channel is also going to act to support it. Good stuff.
Now this next middle beam is going to be 36 and 5/8, and I'm just using like a little tiny flathead as a scribe
until I drop it. Hello again. Man, the lift sounds really nice right about now. Second cross member. This will also be supported by parts of this existing cross member. I don't know what you call this. I'm not a structural engineer. Is it positive connection? Not sure. But I really like the way so far that these first two have landed, because let's just say I'm not exactly the most experienced welder. Also, can we just take a moment to appreciate, I know there's been a previous repair, but just how good this frame looks. The bed, not so much, but can't have everything. Only have one more to cut, and that one's gonna land right about here. Do right there. Shimmy around the brake line. We're gonna be welding a little close to some brake lines. Man, I don't mean to toot my own horn, especially because it took me 2 cuts, but I do not need any magnets. This side's sagging a little bit. That's fine. I'm gonna double check dimensions for each one of these and then tack them in place. This is going a little too smoothly. Something's gonna happen. 14.5 from the back rail to the center rail, 25.25 from the back rail to the front rail. That's on the driver's side. 14.5, 25, and I'd say closer to 3/8. Boom. Always double or triple check. On this side, we're going to move it to the front about 1/8 or 1/4 inch. What I'm going to do is I'm going to tack these 3 rails on the driver's side in place since they're laid out correctly right now. And then I should, as long as I just do tack welds, should have enough play. If I need to move any of these 1/4 or 1/8 inch around, then should be able to hammer them into place. What? You could tell that I'm not a seriously experienced welder with 20 years of experience? What gave it away? How did you know? In all seriousness, I know this is a tiny, super cheap machine with dials and displays that don't even necessarily make sense, but the factory frame on this Toyota is 1/8 inch steel. The angle that I got is 3/16. I'm sure it's plenty strong, but it's also pretty soft, I could tell just from cutting it. So I'm hoping that this will do the trick. Harbor Freight special electrodes. Also going to practice a little bit on some of the scraps that I cut off. Also, I thrifted this canvas button up, or canvas zip up, sorry. And we're gonna call it a welding jacket. Just gonna try straight on it after, or to begin with. Okay. One of your first times welding, why not do it upside down in a confined space? Is that a tack weld? I think it might be. Alright, we got it up on the transmission jack here. Do not look at my welds, I'm literally going to have to cut out and redo all of them. Still pretty new on this machine. It is landing right where we want it. You can see looking down the line there, those holes are centered. Back here, they're centered. And third and last rail centered on that. You're going to get neoprene shims here to provide a little bit of cushion, just so we don't have hard metal on metal contact. Probably get a 1/4-inch neoprene shim for each one of these. That'll be fastened through there. This is great. Now that it is in its final spot, I'm going to center punch or just mark out each hole so I can drill through here. Then I can pull it down, touch up any welds, and throw some paint on each one of these rails. New day, new drill bit, because the last one was just not doing it. DeWalt bit, Ryobi drill. Hopefully it doesn't blow up. It didn't fall down yet. Well, I would say that aside from some touching up to do on the welds, that this came out pretty good. Just got a few bolts thrown in here for the mock-up, but I like the way that came together. So our next step is going to be dropping this back down, drilling the rest of the holes, and getting the batteries and the battery management set up in this thing. And that's when this will really start coming together. That's going to be all for this video, guys. If you stuck around till the end, I really appreciate it. And if you have any welding tips, feel free to leave them in the comments. I'm open to just about any suggestions. If you enjoyed the video, please leave a like and consider subscribing if you want to follow along for the rest of this build. Should be pretty exciting as we get going with the batteries here.